Hello and welcome. In this video, we're going to be talking about integration using partial fractions method, or how to integrate questions using the partial fraction decomposition method. So before knowing how to work out with this method, we need to know which type of questions are the questions that require partial fraction decomposition. So let's take a look at a question that looks like this. Let's say we have integration of x plus 14 over x plus 5 times x plus 2. How can I integrate this using the methods that we talked about in the previous videos? I cannot do u substitution over here, because if I try, I will not find the u, and then when I substitute this du with something, this dx with something in du, I will not find something that will cancel with this. So basically, u substitution wouldn't work. By parts also wouldn't work. So what can I do here? What if I rewrote this into an easily integrable form, or a form that is easily integrationable or easy to be integrated? Okay. So first of all, I'd notice that this is a proper fraction. Proper fraction means that the degree of the numerator is less than the degree of the denominator. So we can see that the numerator has a degree of 1 and the numerator has a degree of x times x, so x squared. So this is a proper fraction. So please note that partial fraction or integration using partial fraction only works for proper fractions. Okay, so let me give you a simpler example. Let's say we have 1 over 3 and we want to add to that 2 over 2, for example, 2 over 5. Okay, so using algebra that we were taught, we need to make the denominator common. So I can do is multiply here 5 over 5 and multiply here 3 over 3. So this is going to be 5 over 15 plus 6 over 15. Now I can add them together. 5 plus 6, that's going to give me 11 over 15. Okay, so what we are doing in partial fraction decomposition is the other way around. We start with this fraction, like this fraction, and we try to write it as the 1 over 3 plus the 2 over 5. So we need to find these two forms. Okay, this is basically what we are doing in partial fraction decomposition. So let's see how we can do that. Let's say this, let's just copy this fraction, okay, and paste it over here. Okay, let's say we can rewrite this fraction as a, which is some factor, okay, a is a constant, okay, over x plus 5, which is the first linear term over here, plus another constant b over x plus 2. So I need to equate this to something that looks like this. So I need to find my a and b. So how can I do that? Let me try multiplying everything on both sides by these two. So multiply everything by x plus 5 times x plus 2. So I know that when I multiply this left side by x plus 5 times x plus 2, this and this are going to cancel. So I'll be left with x plus 14 on the left side, equal. When I multiply this term by x plus 5 times x plus 2, I know that x plus 5 is going to cancel with x plus 5, and I'm going to be left with a multiply x plus 2, plus similarly for b, when I multiply these two terms, x plus 2 is going to cancel with x plus 2, and I'm going to be left with b multiplying x plus 5. Okay, so over here I can find my a and b. How can I do that? By substituting some x values that I would choose. So let me choose a smart x value. Let's say I will choose my x as -2. Why did I do that? Because I know if I substitute this x with a -2, this whole term will be 0 and a will be cancelled from my equation, and that way I can find b. So let's see how that will work. So when x is minus 2, okay, I will have minus 2 plus 14, that is 12, equal a multiply minus 2 plus 2, that is 0, so basically 0a, plus b multiply minus 2 plus 5, that is 3. Okay, so over here I will have 12 equals 3b, and very easily I can divide both sides by 3 to get b equals 4. So let's write over here that b is 4, and let's erase this. So now we found our b. Let's substitute something else. Let's substitute x equals, let's say, minus 5 to cancel this and make my calculations easier. So minus 5 plus 14, that is going to be 9, equals a multiply minus 5 plus 2, that is minus 3, plus b multiply minus 5 plus 5, that is 0, so this term is going to be 0. So I will have 9 equals negative 3a, which gives me a as 9 divided negative 3, which is negative 3. So my a is negative 3. So I can come over here and substitute the a over here with a minus 3, and the b with a value of 4. So now, rather than integrating this, I can now say that this is equal to the integration of negative 3 over x plus 5 plus 4 over x plus 2 with respect to dx. Why? Because this is exactly the same as this, correct? So I can say that. And why does this help me? Because now the integration becomes so much easier. So I will integrate this first term, okay? I can use u substitution, or you know this super quickly with a practice. You will know that this is gonna be, this is similar to integration of minus, let's say, minus 3 times 1 over x plus 5, okay? So this is equal to minus 3 ln of x plus 5, dividing the integration, dividing the integration of what's inside, dividing the differentiation of what's inside. So the differentiation of x plus 5 is 1, so over 1, or basically that's it, okay? And for this part, similarly, I will have 4 times the integration of 1 over x plus 2. This is going to give me this dx. This is going to give me 4 times ln of x plus 2. So my answer for this integration is going to be minus 3 ln of x plus 5 plus 4 ln of x plus 2, and I cannot forget my constant of integration. So this is the integration of this question over here, and this is how to use partial fractions, okay, to make your life easier. So what I want you to know here is that before using partial fraction, you need to make sure that it's a proper fraction, okay? And also we have different forms that the proper fraction can come with, okay? And we will take a look at all of these forms. So for our first form, let's write them over here. So our first case, when we have something that looks like this, so px plus q over x plus a times x plus b, let's say, okay? This I can rewrite it as just like what we did. And also I don't want you to pay a lot of attention for this px plus q. It doesn't matter if this is a degree of 1, degree of 0 degree, as long as it's just a degree that is lower than the denominator degree, then you can use what I'm telling you right now. So this is very similar to the question that we've done. So you can rewrite this as a over the first linear term plus b over the second linear term, okay? Similarly, we can have more than 2 linear terms. So let's say this is x minus a times x plus b times x minus c, for example. So again, this I can write it as a over the first linear term plus b over the second linear term plus c over the third linear term over here. Okay, now, the third case that I can have is something that looks like this: px plus q over x minus a all squared. Okay, so again, the degree of the numerator is less than the degree of the numerator. This we can write it as a over x minus a plus b over x minus a squared, and you need to take care of this. Okay, this is called a repeating linear factor. Okay, because I have this x minus a, which is a linear factor, it's repeating, it's squared, so it's x minus a times x minus a. When we have something like this, we keep on adding terms and increasing the power by 1 until we reach the maximum power. So for example, if this was x minus a cubed, then I will add plus c over x minus a cubed. If this was to the power of 5, then it's going to be x minus a times x minus a plus b over x minus a squared plus c over x minus a cubed plus d over x minus a power 4 plus f over x minus a power 5, and so on. Okay, so this is super important and super to distinguish that we have a repeating linear factor. Okay, so another case that we can see is that when we have a quadratic factor, so let's say p, we have the numerator as px plus q again, over, let's say we have a linear factor times a quadratic factor. Okay, how do we deal with this? First of all, for the linear factor, it's super easy, just a over the linear factor, and then this quadratic factor should be irreducible or non-factorizable. Okay, because you could tell me, okay, we had an x minus a squared over here, why didn't you consider it as a quadratic? No, when we have an x minus a all to the power of 2, this is considered as a repeating linear factor because it can be factorized further. However, when we have a quadratic that cannot be factorized further, then it looks something like this. So we finish this linear term part, a over x minus a plus bx plus c over x squared plus bx plus c. So now your numerator here is no longer only one term, it's bx plus c. Okay, so it's no longer just single term with 0 power. No, it's now a linear term. So these are the cases that we need to know in order to solve any of those questions. So let's do what's best for you, which is taking some examples, and we can return back to this to compare our example with the cases and know which one we should use. Okay, so let's say we have integration of 4x squared minus 7x minus 12 over x times x plus 2 times x minus 3 dx. Okay, so this, we have 3 linear factors. Okay, so this is similar to this. Okay, I just have 3 linear factors, so I'm gonna write it, use the second case to solve. So this is going to equal a over the first linear factor plus b over the second linear factor plus c over the third one over here. And again, this is the same as integration of this with respect to dx. So what I can do is multiply both sides by x times x plus 2 times x minus 3. Okay, we're multiplying both sides by this expression over here. So this whole expression will cancel with this whole expression. That's the whole point. So you will have on the left side only 4x squared minus 7x minus 12. This is going to equal, okay, when I multiply this by this a over x term, the x and the x are going to cancel, and we're going to be left with a times x plus 2 times x minus 3 plus, again, when I multiply it with this second term, these are gonna cancel, so we're gonna be left with b times x minus 3 plus, again, now the x minus 3 term is gonna cancel, so we're gonna be left with c times x plus 2. And over here, this is a step where we choose our x's, okay, in order to solve, okay. So straight away, I can see that if I chose, let's say my x is 0, so this is going to be 0, this is going to be 0, this whole term and this whole term are going to cancel, and I can then find a. So let's try and do that. So x equals 0. Let's do this. So x equals 0. 4 times 0 is 0, minus 7 times 0 is 0, so I'm going to have a minus 12 on the left side, times a into 0 plus 2 is 2, 0 minus 3 is minus 3, plus this term is going to be b times 0, plus c times 0, so these two cancel, I don't need to include them. So I'm going to have minus 12 equals 2 times minus 3 is minus 6a, which is going to give me a as dividing minus 6 both sides, so it's going to be positive 2. So this is my a. Let's write it here. A equals 2. And let's erase this. So now we found our a. Let's say we will substitute x with a smart value. Let's say we substitute x with 3. Why 3? Because when it's 3, this whole term is going to cancel, because 3 minus 3 is going to be 0. This is also going to be 0, and we can find c. So let's try and do that. So when x equals 3, we will have 4 times 3 squared, which is 9, minus 7 times 3 minus 12, equal to, this whole term is going to be a times 0, plus this whole term is going to also be b times 0, plus this is going to be c times 3 plus 2 is 5. So over here, I will have 4 times 9 minus 7 times 3 minus 12. This is going to give me 3 equals, this is 0, this is 0. 3 times 5 is 15. C. So c equals 3 over 15, which is 1 over 5. So let's write this over here. C equals 1 over 5. Now let's erase this whole part and do our final substitution. And you may guess this. Try to guess which value I'm going to substitute. If you guessed minus 2, then you are correct. There is no correct or wrong, but this is the easiest way because this is going to cause the most cancellations. We're going to have 4 times minus 2 squared, that is 4, minus 7 times minus 2, minus 12, equal to minus 2 plus 2, that is going to be a 0 term, so it's going to be a times 0, plus b times minus 2 times minus 2 minus 3, that is minus 5, plus, okay, when I put a minus 2 over here, minus 2 plus 2, that's going to be 0, so it's going to be c times 0. So over here, I will have 16 plus 14 minus 12. This is going to give me 18 equal, this is 0, minus 2 times minus 5, that's plus 10b plus 0. So b is going to equal 18 over 10, which is 9 over 5. So now b equals 9 over 5. So now I'm ready to rewrite my integral using the values of a, b, and c that I got. So a is, let's erase a, b, and c. We will replace a with 2, b with 9 over 5, okay, and c with 1 over 5, okay, and then I will have to integrate this over here. So integration of this is going to be integration of 2 over x. This is going to be ln of, this is going to be 2 ln of x, plus this is 9 over 5 ln of x plus 2, and then plus 1 over 5 ln of x minus 3 plus c, and this over here is the answer I am looking for. Okay, let's take another example. Let's erase this example over here. Okay, let's take another integral. Let's just erase this. Okay, let's say we have an example that looks like this. We have the integration of 5x minus 2 over x plus 3 all squared dx. Okay, how does this look like? You might come and tell me, okay, first of all, this is a proper fraction. Yes, the degree on the numerator is 1, the degree down is 2, so we can proceed with partial fractions. Over here, you can tell me, okay, this is a quadratic factor, so we will use bx plus c over the quadratic factor. I tell you no, this is incorrect. Because if you look, this is a repeating linear factor, and for repeating linear factors, we do something like this. So this is going to equal the integration of a over x plus 3 plus b over x plus 3 squared, and this is under the square root. If you want a video of why does this work, I will show you. Probably I'll upload a short after this video showing why does this happen. Okay, so let's get into what we will need to do. So we will multiply both sides by x plus 3 all squared. So when we multiply this first term, this and this is going to cancel. This is the whole point. 5, and we'll be left with 5x minus 2. A over x plus 3 times x plus 3 squared. 1 is going to cancel with this x plus 3. So we will have a times x plus 3 plus b. This and this are going to cancel when you multiply an x plus 3 squared. So we will only be left with b. And right now is the point where we need to substitute. So let's substitute x as minus 3 to get rid of this a term. Okay. So this is going to be 5 times minus 3 minus 2 equals a times 0 plus b. So this is going to be 5 times minus 3 is minus 15, minus 15 minus 2, that's minus 17 equal b. So our b equals minus 17. This is the first term. Now let's do another substitution, okay, to find a. Now we cannot cancel b, however, we know its value. It's minus 17. So now we can do any substitution. I prefer to substitute 0 over here. This is going to make me have a lot less numbers. So this is going to be 5 times 0 minus 2 equal a times 0 plus 3 is 3 plus b, and I know that b is minus 17, so it's plus negative 17. So this is going to be minus 2 equals 3a minus 17. Adding 17 to both sides, 17 minus 2 is going to be 15 equal 3a. Dividing 3 both sides, that will give me an a value of 5. So my a value is 5 over here. And now I'm ready to do my substitutions. So instead of a, I'm going to put in a value of 5. And instead of b, I'm going to put in a value of minus 17. Okay? So let's now try to integrate this new form over here. So for the first term, which is integration of 5 over x plus 3, this is going to equal, okay, ln, this is going to be 5 times ln of x plus 3. Okay, and then what's the integration of this term? Let's do it in this space over here. Integration of, I'll put the negative 17 outside, minus 17 of 1 over x plus 3 squared. with respect to dx. So what I can do here is I can do a use substitution, and by the way, I have a full video on how to do use substitutions. I'll leave it on the top right hand corner. Feel free to go check it out, super useful. So I can say that my u is going to equal x plus 3, okay? That makes my du equal to 1 times dx. So I can do the substitution, so it's going to be minus 17, integration of, instead of x plus 3 is going to be u squared. Instead of dx, it's basically du. So this is similar to negative 17 integration of u to the power of negative 2 du. Doing the integration very, very simply, power rule, I will add 1 to the power. This is going to be negative 17 u power negative 1 over the new power, which is negative 1. So negative and negative are going to cancel. This is going to be equal 17 u power negative 1, or basically 17 over u. And doing the substitution back, 17 over, instead of u, I'm going to put x plus 3. So this is the integration of this second part. Okay, so I can erase this. And I know that this is going to be plus the integration of negative 17 over x plus 3 squared, which turned out to be 17 over x plus 3. And then I'm going to add the constant of integration, and this is going to be my answer to this question. Okay, let's erase this and take another example. So let's do this. Let's say we have the integration of 5x squared plus 3x minus 2 over x cubed plus 2x squared dx. First of all, the degree of the numerator is 2, the degree of the denominator is 3, so this is a proper fraction, so we can proceed with partial fraction integration. But however, this is still factorizable. What I can do is I can rewrite it as 5x squared plus 3x minus 2. I can take an x squared out common from here. I'll be left with x cubed divided x squared is x. 2x squared divided x squared is 2. So now this is my form over here. And how does this look like? What's this first term over here? Actually, no, let's take this one. What's this? This is a linear term, so I'll expect to have something that looks like this. Okay, so let's say equal to a over x plus 2. What about this? Is this a quadratic? Okay, is this a quadratic or a repeating linear factor? This x squared is still factorizable. It could be written as x times x. So this is considered as a repeating linear factor. So we consider it as case number 3. So what we do is this is going to be plus b over x plus c over x squared. And this is how to do your constants. Okay, and now all we have to do is to find them. As usual, we will multiply everything by x squared plus times x plus 2. So multiplying this by that, this is going to cancel. We will only be left with 5x squared plus 3x minus 2 on the left side equals a over x plus 2 times this. X plus 2 is going to cancel, then x plus 2 will only be left with a times x squared plus b over x. So 1x is going to cancel with this x. We're going to be left with x times, let's write the b first. So b times x plus 2 plus c over x squared. Multiply this expression, x squared and x squared are going to cancel. We're going to only be left with c times x plus 2. And now we can proceed to find our constants. So as usual, we will substitute. I can see that if I substitute x with 0, this is going to cancel, this is going to cancel, and I can find c. So let's do that. X is 0. This is going to be 0. This is going to be 0, 0. So I will only be left with minus 2 on the left side equal a times 0 plus b times 0. This is basically b times 0 times 0 plus 2. So it's equal to b times 0 times 2. And anyways, anything times 0 is basically 0. Plus c times 0 plus 2. So minus 2 equals, this cancels, 2c. So this gives a c value of minus 1. So we can rewrite over here that c equals minus 1. Now, let's erase this and try to substitute something else to cancel one more factor. So I can see that if I substituted x equal minus 2, this is going to cancel, this is going to cancel, this is going to become 0, this is going to become 0. So let's do that. X equal minus 2, this is going to be 5 times minus 2 squared is basically positive 4 plus 3 times minus 2 equals a times minus 2 squared is times 4 plus 0, this term is 0, and the other term is also 0. So 5 times 4, that is 20. 20 minus 6 is 14. 14 minus 2 is 12, which is equal to 4a. This gives an a value of 12 over 4, which is 3. So a equals 3. Now, let's do final substitution. Over here, we have the value of a and we have the value of c. So if we substitute any x, we can find the b value. So let's choose a simple x value. Let's choose 1. Okay, so this is going to be 5 times 1 squared, which is 1, plus 3 times 1 minus 2 equals a is 3 times 1 squared, so times 1, plus b times x, which is 1, times 1 plus 2 is 3, plus c, which is minus 1 times 1 plus 2 is basically 3. So I have over here 5 plus 3, that is 8. 8 minus 2 is 6, equals 3 plus 3b minus 3. So this 3 and this 3 will cancel. I'll divide 3 both sides. So this is going to give me a b value of 2. So now I have b equals 2. And I can rewrite my partial fraction. Instead of a, I'm going to put in 3. Instead of b, I'm going to put in 2. And instead of c, I'm going to put in minus 1. And now I can do my integration. So the integration of 3 over x plus 2 is basically 3 ln x plus 2 under the modulus. This is called modulus because we cannot have a negative value inside the ln function, plus integration of 2 over x is basically 2 ln of x, and then this over here is the same as integration of minus 1 times x power negative 2 dx. So I will add 1 to the power, so this is equal to minus 1 times x power negative 2 plus 1 is negative 1 over the new power, which is negative 1. These two cancel, so this equals to x power negative 1 or 1 over x. So plus 1 over x plus c. This over here is my answer to the question. Okay, let's take one more example. Let's erase all of this. Okay, let's say we have an example that says we need to find the integration of 10 over x minus 1 times x squared plus 9. Okay, let's see each term and figure out what type of term is this. This is a linear factor, normal linear factor, so I'd expect to have an a over x minus 1, let's say. What about this factor? It's a quadratic factor. First thing I need to ask myself, is this factorizable? Can I factorize this more? If I can factorize this more, then I can factorize and see what other factors I get. However, if it's an irreducible or unfactorizable quadratic, then it's this case over here. It's similar to this case. Okay, so this is gonna be plus bx plus c over the quadratic factor, which is x squared plus 9. So now I have my integration and my unknowns, which I will need to find. So as usual, we're going to multiply both sides by x minus 1 times x squared plus 9. These two are going to cancel with these two, so we'll be left with 10 on the left side, equal to, when I multiply a over x minus 1 times this expression, x minus 1 and x minus 1 are going to cancel. I'll be left with a times x squared plus 9, plus when I multiply this with x squared plus 9, this x squared plus 9 and x squared plus 9 are going to cancel. I'll be left with bx plus c multiplying x minus 1. Now I will do my substitutions to get my values. So first of all, I can straight away tell that if x is 1, then this whole term is going to become 0. So on the left side, 10, so let's say x is equal 1. 10 equals a times 1 squared is 1 plus 9 is 10. Plus I said this whole term is going to become 0, so this everything here is going to become 0. So 10 equal 10a, so that gives me an a value of 1. Okay, let's do another substitution. I know that if I substituted x equals 0, this term over here is going to cancel. So let's see. Let's say x equals 0. So we're going to have a 10 equals a times 0 plus 9 is 9, plus b times 0 plus c times 0 minus 1 is minus 1. So this is 10 equals 9a plus this term is 0. This is going to be negative c. So now I have one equation over here that I can work with. So I will need another equation to that involves a and c. So let's substitute one simple value of x again. So let's say x equals 2. And as you can see, here I cannot cancel anything because I cannot substitute any x that will cancel this term over here. So I will need to do two substitutions and then solve the equations that I get simultaneously. So this is going to be x equals 2. So 10 equals a times 2 squared is 4. 4 plus 9 is 13. And I know that my a, my a value is 1. So from here I can say that 10 equals 9 times 1 minus c. So moving this 9 to the other side, 10 minus 9 is 1 equals minus c. So this gives me a c value of minus 1. Actually, I can find c straight away. So c equals minus 1. Okay. Now, let's do again substituting x equals 2. So instead of a, I know that the value is 1. I calculated that. So 1. Plus, okay, I don't know what's b, so I'm going to say b times x is 2 plus c. So what is c? C I got as minus 1. And then x, which is 2. 2 minus 1 is basically 1. So over here, I'll have a 10. I'll move this 13 to the other side. It's going to become 10 minus 13. So minus 3 equals 2b minus 1. So 2b equals minus 2. So b equals minus 1 as well. So these are my values. B equals minus 1. So let's substitute everything. So instead of a, I'm going to put in a value of 1. Instead of b, I'm going to put in minus 1. And instead of c, I'm going to also put in minus 1. So over here, I can perform my integration now. Let's see how we can do the integration. So this first term is very easily integrated. So it's gonna be ln of x minus 1, and then we need to add the integration of minus x minus 1 over x squared plus 9 dx. So how we can do the integration of this term? First of all, let me rewrite it as integration of, I'll split it, it's going to be minus x over x squared plus 9 plus minus 1 over x squared plus 9 dx. Okay, so this term over here, I can use u substitution to solve. So let's say I'm gonna take u as x squared plus 9. That's gonna make du equal to 2x dx. So dx is equal to du over 2x. Let's perform my substitution now. So it's gonna be integration of minus x over u, and instead of dx is gonna be du over 2x. And I can see straight away that x and x will cancel, so this is going to be minus integral of 1 over u du, which is basically minus ln of u. So it's minus ln, I will substitute back u as x squared plus 9. So this term, this is the integration of this term over here. So let's actually erase all of this and copy this term over here. So this is basically the integration of this term. What about the integration of minus 1 over x squared plus 9? So I have a rule which is actually using trigonometric substitutions, which we will have a look in a future video. However, for now, it tells me that the integration of 1 over x squared plus a squared, okay, is equal to 1 over a times tan inverse of x over a. So over here I can say that I have an x squared and a squared is 9, so a is basically 3, right? So I can do the substitution of this term over here is gonna equal minus, because this minus over here, 1 over, what is a? We said a is 3, and then tan power negative 1 of x over a, which is 3 as well. So this expression, this is the integration of the first term, and this is the integration of the second term. So to write everything, the final answer is going to be, this is ln x minus 1 plus the integration of this term is basically this added to that. So it's going to be, so this is a minus ln of x squared plus 9. Okay, and then we have minus 1 over 3 tan power negative 1 of x over 3. And we cannot forget our constant of integration over here. So our answer is going to be ln of x minus 1 this part, actually this part over here, the u substitution that we did, this u substitution, we said this is minus x over x squared plus 9. So we said u equals x squared plus 9, du equals 2x dx. So it's going to be integration of minus x over u times dx, which is going to be du over 2x. So this cancels this, so this is equal to, I forgot the half, so this minus 1 over 2 integration of 1 over u du. So it's equal 1 minus 1 over 2 ln of u, and u is x squared plus 9. So this over here is just minus 1 over 2. I just need to add a minus 1, a half, ln x squared plus 9, then minus 1 over 3 tan power negative 1 of x over 3, and not forgetting my constant of integration. So this over here is how to approach questions using partial fractions all I want you to familiarize yourself with is these 4 cases and knowing how to deal with them. Honestly, the hardest part is determining if the factor is a repeating linear factor or a quadratic factor. The only tip I can tell you, only consider it as quadratic when this quadratic factor is no longer factorizable or reducible. This is my tip. Anyways, please, if you like this video, leave a like, comment down below, and tell me if you have any questions and suggestions for future videos. Subscribe so you don't miss out any new videos. I'm going to be posting a lot. And yeah, thank you so much for watching. Have a nice day.